Hello students, welcome you all to the online class of maths. Today we will be studying the fifth chapter of mathematics, which is understanding elementary shape. Please open your books and ready for the chapter. All the shapes we see around us are formed using curves or lines. We can see corners, edges, planes, open curves and closed curves in our surroundings. We organize them into line segments, angles, triangles, polygons, and circles. We find that they have different sizes and measures. Let us know, try to develop tools to compare their sizes. So, what is a line segment? This is a line. It has no endpoints and extends endlessly in both directions. If you mark 2 points A and B on it and pick this segment separately, it becomes a line segment. This line segment has two endpoints, A and B, whose length is fixed. The length of this line segment is the distance between its endpoints A and B. So, a line segment is a piece or part of a line having two endpoints. Unlike a line segment has definite length. The length of a line segment can be measured either in metric units such as millimeters, centimeter, or customary units like feet or inches. Measuring a line segment. Follow the given steps to measure the length of a line segment. Step 1. Pick up a scale to measure the length of a line segment. Generally, smaller line segments are measured using a centimeter scale. Step 2. Identify the line segment you want to measure. Then, place the tip of the ruler at the straight point of the line segment. Then step 4, read the number on the scale where the line segment ends. In this case, it is 5. So the length of the given line segment is 5 centimeter. So as per the book, there are different types of measuring of line segment. One is comparison by observation. By just looking at them, can you tell which one is longer? You can see that AB line segment is longer. So, but you cannot always be sure about your usual judgment. For example, look at the adjoining segments. So you cannot decide which one is longer or shorter. So you need different type of measuring equipments to measure the line segment. Comparison by tracing. To compare AB line segment and CD line segment, we use a tracing paper. Trace CD and place the trace segment on AB. Can you decide now which one among AB and CD is longer? The method depends upon the accuracy in tracing the line segment. Moreover, if you want to compare with another length, you have to trace another line segment. This is difficult and you cannot trace the lengths every time you want to compare them. Drawing a line segment using ruler and compass. Suppose we need to draw a line segment of length 5 cm. We will follow the given steps. Step 1. Draw a line of any length. Mark a point A on the line, which is the starting point of the line segment. Then step 2. Using a ruler, place the pointer of the compass 5 cm apart from the pencil's lead. Step 3. Place the pointer of the compass at A and mark an arc on the line with the pencil point. Step 4. Mark the point where the arc and the line intersect as B. Step 5. AB is the required line segment of length 5 cm. So you can see in your book how they have used this ruler and divider to measure the length of a line segment. Angles, right and straight. You have heard of directions in geography. We know that China is to the north of India, Sri Lanka is to the south. We also know that sun rises in the east and sets in the west. There are four main directions. They are north, south, east and west. Do you know which direction is opposite to north? Which direction is opposite to west? Just recollect what you know already. We now use this knowledge to learn a few properties about angle. Stand facing north. Turn clockwise to east. We say you have turned through a right angle. Follow this by right angle turn clockwise. You now face south. If you turn by a right angle in the anti-clockwise direction, which direction will you face? It is east again. Why? Study the following positions. You stand facing north. By a right angle clockwise, you now face east. By another right angle turn, you finally face south. From facing north to facing south, you have turned by two right angles. Is not this the same as a single turn by two right angles? The turn from north to east is by a right angle. The turn from north to south is by two right angles. It is called a straight angle. Stand facing south. Turn by a straight angle. Which direction do you face now? You face north. To turn from north to south, you took a straight angle turn. Again, to turn from south to north, you took another straight angle turn in the same direction. Thus, turning by two straight angles, you reach your original position. By how many right angles should you turn in the same direction to reach your original position? Turning by two straight angles in the same direction makes a full turn. This one complete turn is called one revolution. The angle for one revolution is a complete angle. We can see such revolution on clock faces. When the hand of a clock moves from one position to another, it turns through an angle. Suppose the hand of a clock starts at 12 and goes round until it reaches at 12 again. Has it not made one revolution? So how many right angles has it moved? Consider these examples. From 12 to 6, half of a revolution or two right angles. From 6 to 9, 1 by 4th of a revolution or one right angle. From 1 to 10, 3 by 4th of a revolution or three right angles. Now the third exercise of 5th chapter, which is angles or types of angles. Types of angles. Types of angles: acute, right, obtuse, straight and reflex angles. When two lines intersect, at the point of their intersection, an angle is formed. Learning about angles is important as they form the base of geometry. The two rays that form the angle are known as the sides of an angle. Also, it is not necessary that an angle is formed by intersection of two straight lines. It can be formed by intersection of two curved lines too. Acute angle. An angle which measures less than 90 degree is called an acute angle. The measures between 0 to 90 degree. In the picture below, the angle formed by the intersection of PQ and QR at Q forms an angle PQR which measures 45 degree. Thus, PQR is called an acute angle. You can see in the picture all the angles which is shown are less than 90 degree and more than 0 degree. So these are acute angles. Second is right angle. An angle which measures exactly 90 degree is called a right angle. It is generally formed when two lines are perpendicular to each other. In the figure below, line AB intersect line BC at B and form an angle ABC which measures 90 degree. Obtuse angle. An angle that measures greater than 90 degree is known as the obtuse angle. The angle measures ranges from 90 degree to 180 degree. An obtuse angle can also be found out if we have the measures of the acute angle. Straight angle. The angle which measures exactly 180 degree is called a straight angle. This is similar to a straight line, thus the name straight angle. A straight angle is nothing but a mixture of an obtuse angle and acute angle on a line. Reflex angle. The angle which measures greater than 180 degree and less than 360 degree is known as the reflex angle. The reflex angle can be calculated if the measures of the acute angle is given. as it is complementary to the acute angle on the other side of the line. Using the reflex angle, we can find the measures of the acute angle. A measure of acute angle 360 degree minus A measures a reflex angle. You can see here the angle measures 210 degree. So the angle is greater than 180 degree and less than 360 degree, which is a reflex angle. Summary of this exercise. Acute angle greater than 0 degree less than 90 degree. Right angle is equal to 90 degree. Obtuse angle greater than 90 degree less than 180 degree. Straight angle 180 degree. And reflex angle greater than 180 degree less than 360 degree. So we have finished the 3 exercises of chapter 5. So please go through the exercises and complete it and send it to me. Thank you.